Hello everyone. So yeah, today we're going to see kth largest element in an array. I did never think that I was going to make a separate individual video for this question since we've already done kth smallest element, but then I thought since we're starting off, we'll do the starting questions a little more elaborate so that you have a better grasp on the topics, right? So I already mentioned, right, if we are talking about kth smallest element, you have to think about max heap. And if it is kth largest, you have to think about min heap, right? So let's see the example. Let's take 2, 3, 7, 4, 5, and then maybe 1, and then 9. Okay. So the approach 1, it says sort the given array. Sorting, you give 2, 3, 4, 1, 2, 3, 4, 5, 7, and 9. And then the question says k is 3. That is, you have to find third largest element in the given array. This is my first largest element. This is my second largest element. And now this is my third largest element, right? So what you did sorting, and then you have either you find out, then you reverse. If you reverse this array, you'll get 9, 7, 5, 4, 3, 2, 1. And then you take kth largest element, that is 5. Okay. Else, what you do is instead of reversing and then returning kth element, you combine these steps, and what you do, you return n minus kth element, right? So n minus kth element, where n stands for size of array. And now here -1 plus 1, that you'll have to see as per the indexing, if it's 0 based index or you're going for 1 based index, whatever you're calling up your array, right? So this is my approach 1. Since this is going to take O of n log n time complexity, reversing takes O of n, and then returning takes O of 1. This process is going to take constant time complexity of O of 1. It gives it the total time complexity of O of n log n with the space complexity of O of 1. Now let's get to the better approach of doing this, and that goes in by, if I use heaps. I already gave you this hint that if it's the largest element, we go by min heap. And if I have to go with min heap, let's just do this. In min heap, the expected time complexity is what? The expected time complexity is n log k, and space complexity is O of k, because this is the heap size. Correct? Same was for kth smallest element. Now let's take the example again. 2, 3, 7, 4, 5, 1, 9. 2, 3, 7, 4, 5, 1, 9. Sorted it on the basis of descending order, we get 9, 7, 9, 7, 5, 4, 3, 2, 1. And this is my answer. So this is the part I am concerned with, because if I add here, I add here something, anything, if I add here 2 more, 3 more, 0, 1, anything you add here, it does not even, change anything. So you still have third largest element as this, while you cannot change anything on this end of 5, right? Because even if you add an element or delete an element, or if you modify an element that changes it to go from beyond 5 to this side, right? That makes it smaller than 5, you will have issues. Correct, correct, correct. So now why we're going for min heap? Because this is your size now, 9, 7, 5. And 5 is the smallest. So if there is a heap, 5 has to be on the top, and inside you have 7 and 9, which makes you go with min heap. Right? Right. Now, let's just take this. I'm taking this part on the next page. 2, 3, 7, 4, 5, 1, 9. 2, 3, 7, 4, 5, 1, 9. And we're going to do a dry run of the same. This is my min heap with size equals k equals 3. True? Right. Let's take it. One element. 2. No issues. 3. No issues again. 7. Now heap size is equal to k. Next comes 4. Heap size becomes greater than k. So what happens? We have to pop an element. Which element? The smallest element. 2 gets popped off. Again, 5 gets in. What gets popped off? 3 gets popped off. What comes next? 1. What gets popped off? 1. Again comes 9. Again, heap size is 4. 4 is greater than 3. What gets popped off? 4. What is the heap? What is the top of the heap now? It's 5. So if you return now max heap dot top, what do you get? You get 5. Right? And though you may think, this is priority queue based. Why are we not returning front? Because no, its name is priority queue, but we're going to follow all the language similarities with stack top, right? No front. Good with this part. Let's see its coding part. So yeah, int kth largest vector int array int k. This is all that will be passed to you. You will getting a k, you will be getting an array. You have to return what? Int. So let's go in. So since you're using what? Kth largest, you're using min heap. Let's declare a min heap. Priority queue int vector int greater int. Let's call it min heap. I told you already, please give meaningful names that will help you in the longer run. Now, for int I is 0, I less than array size, I plus plus. Min heap dot push array I. Now, if min heap size, because I have to maintain min heap size to what? K. If min heap dot size gets greater than k, what do? I just pop an element. And what will get popped? Since it's a min heap, what will get popped off? The minimum element. Min heap dot top. Min heap dot pop. And what do you return in the end? You return min heap dot top. Just that. Right? You can always put a check like your size of the array, this size, This array size should always be greater than k size. Else you're not going to get an answer. And then they would have given you in the question statement that if this is this, what do you have to return? If that is given to you, then please use that constraint as well, right? You need to keep an eye on the constraints as well. So you'll find I've mentioned the what do you say? Yeah, in the description box, you'll find the GitHub link to the GitHub repository where you can go and view the code for any feedbacks, any questions that you want me to take up, any concepts that you want me to take up. There's a GForm link. You can use the comment box, but the faster method or the better method to approach this thing is to use the GForms link that is already there in the description box. With this, yeah, thank you so much. Bye-bye.